Hi viewers, the last classes were being discussed regarding the organic chemistry. They have been divided into 6 parts, and even the nomenclature was being dealt, and even the concept of hybridization as well. And today we are going to have the new session regarding the current, electricity, then violet. And this is Santhosh Kumar. Welcome to my channel, Sims Academy. Actually, the electricity has been classified into 2 types. One is static electricity and the second one is current electricity. Static, the word itself indicates that rest position. Current in the sense motion. Hence, we define static electricity is a study of electric charges which are at rest. And current electricity, the study of the electric charges which are in motion. Now, in this class, we are going to learn about the concept of electric current, electric field, electric potential, electric potential difference, and electromotive force, EMF. Okay, now already we discussed that in case of static electricity, we have the study of electric charges which are at rest. At rest in the sense, likewise, the process of electrification, we have seen what we do in our childhood is that by rubbing a scale to our hair, and it could attract the pieces of paper. That is nothing but the concept of static electricity. Even when we go near to the television, screen of the television, immediately after it's been switched off, we can observe that our hair gets attracted to the screen. Hence, this is also with the concept of static electricity. Even we have in our intermediate and JEE mains concept, MSET or NEET, we are going to discuss about the Gauss laws and so on. And for this 10th standard, we have only the concept of electric current. That means we are going to study the electric charges when they are in motion. First of all, the substance which can able to allow the electric current to pass through it is called as a conductor. We say it as an electric conductor. The substance which allows electricity to pass through it is called as electric conductor. And similarly, what happens in the electric conductor? Whenever, let us consider an electric conductor. Here, the charge flows from this place, let us say the point A to point B. Let a charge Q flows from a point A to point B. In what time? Let us say it takes a t time. Then the rate of flow of charge, we define it as electric current. Rate of flow of charge. And what are the units for charge? We have coulombs, and for time it is seconds. Hence, electric current units are coulombs per second, or 1 coulomb per 1 second, we say it as 1 ampere. Now, how can we define ampere? Ampere is the amount of current present in a conductor if 1 coulomb of charge flows through the cross section of a conductor for 1 second. If 1 coulomb of charge flows through the conductor for 1 second, then we say the electric current is said to be 1 ampere. Even we can have some numericals over this. How much amount of electric current if charge is given, suppose 1.6 into 10 power minus 27 coulombs of charge flown for suppose let us take 10 seconds. How much is the amount of electric current? Then we say I equals to Q by T, that means 1.6 into 10 power minus 27 by 10. It is 1.6 into 10 power minus 28 amperes. Even we can get the numericals. Even sometimes they may give us I, and we might be asked to find the value of Q. Then transposing to T to that side, we'll get Q equals to I into T. Depending upon the given numerical, we can solve it. Now, coming to electric field. We discussed regarding the electric current. Electric current is nothing but flow of charge per unit time, or rate of flow of charge. What do you mean by rate? Rate means per second. Per second. That means coulombs per second. 1 coulomb per 1 second, we say it as 1 ampere. Now coming to electric field. What is electric field? Suppose, likewise in case of magnetism, around a pole or in the surrounding area of a magnet, let us say, it could able to attract or repel another magnet. That means up to a certain area, up to a certain radius, we can say up to the certain circumference, yes, up to the certain space or region, a pole can show its influence. That means it can either repel or attract another magnetic pole. In the similar fashion, here if I consider a charge, let us consider a positive charge. I am around this positive charge up to some region or space, it could either repel the like charge or attract the unlike charge up to the certain region or space. The space or region around a charge where it can show its influence is called as electric field. In general, we say it as intensity of electric field. The space or region around a charge where it shows or it can show its influence. Now, coming to electric potential. Electric potential. Now, let us take the example of water flowing. Suppose this is somewhat a flat surface. Some water is present over here. Does water flow from this place to this place? Now, when it is like this, no. Why? Because it is straight. Whenever there is some steepness, there is some slope, obviously water flows from higher level to the lower level. Yes? In the similar fashion, okay, before going to that, suppose a charge is present. Now, I would like to bring another charge from somewhere infinity to a certain point in an electric field. Up to this point, I would like to bring. How much is the work done in bringing that charge? We define it as electric potential. It is denoted by the symbol V. That means somewhere outside at infinity point, somewhere it is there, not inside the electric field. Somewhere outside the electric field, a charge is present. I would like to bring that charge from infinity to a point in an electric field. How much is the work done on that charge? We say it as electric potential. Hence, we define electric potential as the work done on charge. V equals to W by Q. Work done we consider in terms of joules. In SI system I am writing. And charge in terms of coulombs. Hence, the units for electric potential are joules per coulombs, or 1 joule per 1 coulomb, we say it as 1 volt. 1 volt. Now, how do we define volt? If we observe carefully here, if 1 joule is nothing but the amount of work done. Coulomb, the charge. If 1 joule of work is done in bringing a coulomb of charge, 1 coulomb of charge from infinity to a point in an electric field, then we say the electric potential is 1 volt. Got it? 1 joule per 1 coulomb. 1 joule work is done in bringing 1 coulomb of charge. From where? From infinity to where? At a point in an electric field. Okay, clear up to here. Now, what is the electric potential difference then? Electric potential difference. In the sense, okay, there are 2 charges over here. Let us say Q1 and Q2. Or only 1 charge that is present at a point A inside the electric field. I would like to bring that charge from point A to point B inside the electric field. Yes? If I move the charge, the movement of charge per unit time, we say it as electric current. When does a charge move? That's what. When does a charge move? Suppose I brought a charge from infinity to a point here in an electric field. This is some electric potential. This end it is at 1 electric potential. And this charge also I brought somewhere infinity to this point in an electric field. Both the charges, the amount of work done in bringing these 2 charges, let us say these are similar charges, is same. Then there is no movement of charges. That means there is no difference in the electric potentials. If I put a charge, that charge doesn't move from here to there. When does a charge move from one point to another point? This is very important. When does a charge move from one point to another point in an electric field? Suppose if I move to the higher position, what is the energy I possess? That energy is called as potential energy. Suppose if I am present on the surface of the earth, I do not fall anywhere. If I am present at the top of the building, if I slip, I fall down. That means when do I fall down? Basically, whenever I am at the higher potential level, or if I possess higher potential energy. In the same manner, if a charge has to move inside the electric field, it should be the 2 points from where the charge should move to where the charge has to move. Those 2 points must be at different potentials, and the difference in these potentials is called as electric potential difference. Likewise, I have taken your example. When does the water flow from one place to another place? From higher position to the lower position. That difference of the levels, we say it as, in case of charge. If charge moves from this point to this point, this is said to be the electric current. When does the electric current is present in the circuit, in a conductor? When does the electric current present? Whenever there is difference between the potentials at the 2 ends of the conductor. If the conductor is like this, no charge flows. If one end of the conductor is at a higher potential and the other point is at a lower potential, then only the charge flows. Whenever the charge flows, current exists in the conductor. That means the difference in the potentials of the 2 different points inside the electric field is called as electric potential difference. Whenever the electric potential difference exists in a conductor, obviously the charge flows. The flow of charge per unit time, we say it as electric current. That means whenever we have the electric potential difference between the two ends of the conductor, obviously there will be electric current in the circuit. Yes. Now we define, how can we define this electric potential difference? That means at somewhere higher point to this charge has to move. This is the electric field. The charge has to move from point A to point B. The point A must be at higher electric potential and the point B must be at a lower electric potential. Now that charge moves from A to B. How much is work done on that charge from A to B is called as electric potential difference, or in general we define electric potential difference as the work done in bringing a unit charge from one point to another point, from one point to another point in an electric field. Electric field లో ఒక పాయింట్ నుంచి ఇంకో పాయింట్ దగ్గరికి చార్జ్ తీసుకెళ్ళడానికి ఎంత అయితే వర్క్ అవుతుందో the same we say it as electric potential difference, and the units are same for electric potential difference also, because the work done is on charge. But in case of electric potential, we are bringing the charge from somewhere point infinity to a point in an electric field. But in case of electric potential difference, we are bringing the charge from one point to another point inside the electric field. That is the small difference between these two. Now coming to electromotive force, EMF. We say EMF. Before going to learn about EMF, we use cells or batteries. In what way we know the symbol for battery? Let us consider, construct a small switch K. We have a power consumer like an electric bulb. This is a battery B. This is a power consumer, electric bulb B. Oh sorry, electric bulb E. EB, electric bulb. Okay, this is the power consumer. This is the power source, and this is key. When the key is closed, what happens? Obviously, there exists. This is in case of battery, the longer line indicates the positive charge, and the shorter one indicates the negative. The current always moves from the positive terminal of the battery to the negative terminal of the battery. That means we consider the direction of positive charges as the direction of conventional current. That means in our daily life, we consider positive charges as the direction of electric current but not electrons. We speak about electrons, but we consider the direction of positive charge always. Hence, the current here, this is the direction of electric current. Yes. Hence, what is the energy that is stored in the battery? What is the energy that is stored in the battery? Which energy? Yes, chemical energy. The energy that is stored in the battery is called chemical energy. That energy applies some force here. Yes, that energy applies some force. Whenever force is applied on a charge, it obviously moves. Am I right? The charge moves whenever some force is applied. That means force, it moves to a certain distance, we say it as work done. Yes, work is done on what again here? Work is done on charge. Let us say it as charge Q. That means the work done by the cell, on these charge carriers to move from the point of, this is the positive in the sense we say it as higher potential, and this is negative, it is nothing but lower potential. That means the work done by, what it is? The cell or a battery on the charge carriers to move them from the point of, this is higher potential, to the point of lower potential, is called, we say it as EMF, Electromotive Force. Because of this EMF of the cell, work is done on charge. This is also same, joule per coulomb, or 1 joule per 1 coulomb, we say it as 1 volt. That means here, the students, we have discussed regarding the division of electricity. Electricity has been classified into two types, static electricity and current electricity. Static electricity deals with the charges at rest, current electricity deals with the charges in motion. And even we discussed regarding the charge units are coulombs, and charge we generally denote it with small q or sometimes capital Q, no issue for that. And next we discussed with the electric current, the rate of flow of charge is called as electric current. This is I equals to Q by T, and here I will write here I equals to Q by T, and its units are coulombs per second or amperes. And even for electric field ladder, we can go on with that. Electric potential, work done on charge, that is joule per coulomb or volts, we say. Electric potential difference, the same one, work done on charge, joule per coulomb or volts. And electromotive force, E also, work done on charge, joule per coulomb or volts. This is about the today's session, and one question I would like to ask you is that, is electric current a scalar or a vector? Charge is a scalar quantity, work done is a scalar quantity, but is electric current a scalar quantity or a vector quantity? Think until we get for the next session. And in the next session we are going to learn regarding the Ohm's law verification, resistors, and on what factors does the resistance of a conductor depend on. Hence, please do subscribe to my channel, my dear viewers, and thank you for watching to my beautiful class over here. And stay home, stay safe. This is Santhosh Kumar from Sims Academy signing off. Bye.